Hello everyone, welcome to Discrete Mathematical Structure, Module-2, Session-9. So in previous session, I was discussing about the permutation along with the combination, and here we have just looked into how exactly we are going to look into combination and a few examples with respect to combination. And in a given scenario, either should I think about permutation or should I think about combination. And even I just given you this problem. I just gave you this problem and I just asked you to try on this. Fine. So if you have tried, I hope you might have understood whether you should use a combination or you are going to use a permutation. So now in this class, so let me first address this particular problem and let me help you to understand how exactly this problem was supposed to be solved, and later on I'll be just taking you to the next concept. Fine. Fine. So the question what I have just given you was, so we are going to have an word, so which is going to something called as TA, just going to something called as TA, LL, TA, LL, AHA, SSE. So right now, forget about how exactly we pronounce this word, but later on we'll see what exactly it is. But right now what my major focus here is on how exactly I am going to use this, because this is the given word and I need to see how many arrangements I can make out of this. Fine. Now what is the number of ways how I can make arrangement of this given word. So now in this case, whenever I am going to say how many arrangements, you are going to think about permutation, and you know how to use or how to make use of permutation. So now I am not saying exactly how many objects you need to pick. I am not mentioning you the R objects. Hence by default it is understood that the value of R also is going to be same as N. Hence for the given all this set of characters, you need to now find how many arrangements. So now for that, so when I am going to say how many arrangements, usually I am going to use the permutation, that is I am going to use P of N comma R, P of N comma R, so which you already know, which is going to stand at N factorial divided by N minus R factorial. So now what is the value of N? So N is going to be the number of characters in the form of number of objects, and so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Hence the value of N is going to be 11. And now what's the value of R? It's not given, hence I need not bother about R. So R will be same as the value of N. So now whenever the value of N and R are same, that is, so N minus R will be 0, 0 factorial is 1. Hence straight away I am going to say this as N factorial. And so whenever the value of N and R are same, so P of N comma R is going to be just as N factorial. And I know what is the value of N, but if you carefully observe, there's one more thing which you need to carefully look into and analyze and see that we are going to have the same object repeated more than once, hence distinct object, but there are identical objects. Whenever the objects are distinct and I am going to have identical objects, you are going to talk about frequency. Hence, so first work on the frequency, and that frequency should be divided by this, because whenever there is going to be some sort of frequency or identicalness in the object, I am going to divide this by N1 factorial multiplied by N2 factorial, so on Nk factorial. Hence for this I need to find, I know what is N, it's 11, but now I need to find what is N1, N2, so on until Nk. So now for that, so we are going to take T, which will stand it as N1. Now how many T's are there here? The frequency of T's, what do I mean? So it's going to be 1. I am going to have N1 is going to be 1. Now what about A? I am going to have A as N2. So which is going to have 1, 2, 3, Hence the frequency is going to be 3, N2 is 3. Next let me take this as L, which is going to be N3. 1, 2, there's going to be 2 frequencies. I'm going to have 2, and A is done. I'm going to take up at H. So H equals N4 equals, how many H are there? It's only 1. And I'm going to A is done. I'm going to have S, and I'm going to have E. Hence I'm going to have S equals N5, which is going to be 2, and E is going to be N6 again, which is going to be 2. This is the number of frequencies what I have been found and which I need to divide with. And so let us do this now. I'm going to have this as now. So P of 11 comma 11 is equivalent to 11 factorial divided by n1 is 1 factorial. So let me avoid writing this, because we know 1 factorial will again stand at 1, hence including 1 factorial or excluding 1 factorial right now in our computing factor doesn't factors much. Hence for that reason we are not going to use n1, which is going to be 1 factorial. So let me use 3 factorial, because this matters in the division, and 2 factorial. So multiply this with 2 factorial, again multiply with 2 factorial, and again with 2 factorial. Now this is how this is going to. So solve this, and you are going to find how many ways you are going to have the arrangement. So once whatever the value you get at this point of time, so this is going to be the number of arrangements, of a given word. Fine. So this is by part of job is done. So which forced me to use permutation by understanding what exactly I was supposed to do. So now the next part of the problem, what it says, there should not be any adjacent A. Fine. So in this whole thing, whenever I'm going to put into this certain things, so they should not be the arrangements what I'm going to have, they should not be adjacent A's. Now how do I solve this? So this is something a different scenario where right now I am in. Now to understand this particular problem of how exactly I'm going to deal with not having the A's, not having the adjacent A's. That is, I am not supposed to have 2 A's when I arrange this word. I am not supposed to have any 2 A's together. If I say any 2 A's not together, it's understood that even 3 A's also should not be together. And so now we'll just type. Now this is the total number of ways, which also includes all the combinations, all the arrangements, and this arrangement also includes the adjacent A's also. So now what exactly I am going to do here is, I am going to find how many ways are there where I can have no adjacent A's. How many ways with no adjacent A's? So to solve this problem, I am going to take all the characters, that is leaving out A's, take all the characters, hence so A I'll be not taking out here, so L, and this is going to be L. I'm going to remove this, H, again remove this, yes, E, and E. Fine, so I have removed all the 3 A's now. Fine, so now this should not be adjacent. So what do you mean by this should not be adjacent? Some characters should be in between 2 A's, and the 2 characters should be, at least 2 characters should be between 3 A's. Fine, this is something like what I am going to think about no adjacent A's. So in that term, so just find how many positions are available here, where I can insert the A's. Because I can put A over here, I can just insert A over here. If I insert 1 A here, fine, I can insert the second A only after T, because I cannot insert immediately after this A, which makes it as adjacent E. Hence for that reason, I am going to have second A over here, and similarly I can have 3 A's here, and this is not the only combination. I can shift this. Either I can have first A here. If I am going to have first A here, I can have second A here, and I can have the next A over here. And again, this is not the only position available, and this is not the only combination. Similarly, I can put in between H and S, in between S and S, and in between S and E, and in between E and D, and as well as the last character. So these are the number of positions what have been identified in such a way that I am making sure that the A's will not be adjacent. Fine. So now just see how many positions are available. So 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 positions. There are 9 positions. So which is going to help me? Which is going to help me not to have adjacent A's. Fine. And how many A's are there? There are 3 A's. There are 3 A's. So now to fill this, now I am going to have 3 A's, and now this 3 A's can be filled among 9 positions. Fine. So this means I am going to now think about combination. I am going to think about combination, because so having 3 A's, either in this case this is the one combination, I can have this 3 as second combination, or this 3 at this 3 positions, or this 3. I am going to have put 1 A here and the other 2 A's over here, or 1 A here, 1 A here, 1 A. I am going to have different types of combination. Now, how many such combinations are available? So just listen the word what I am using, combination. Fine. So right now, because having 1 A here and the second A, third A is same as having second A over here, first A over here, and the third A over here. So arrangement never matters to me now. I just want to pick the 3 A's and the 3 positions. I need to pick 3 A's and the 3 position. So now how many positions you need to pick? 3 positions. Out of available how many positions? 9 positions. And the available position becomes n, and the number of positions what I want to select now to insert the 3 A's becomes the value of R. Hence, in this case, the value of n is going to be 9, and the value of R is going to be 3. And as the order doesn't matter now, hence it's going to be a combination for me. And so now I'm going to think about combination. So which is going to be C of n comma R, and we know what is C of n comma R. That is going to be n factorial divided by n minus R factorial into R factorial. So now you know what is the value of n, what is the value of R. Hence I am going to substitute that 9 comma 3, which is equivalent to, so 9 factorial divided by 9 minus 3 factorial into 3 factorial. So solve this, you will get to know how many ways are there, so that I can have an arrangement of these characters without having adjacent A's. Fine. And this is the total number of arrangements. This is the total number of arrangements where the A's are not adjacent. So this is how I am going to look into problem. This is how we are going to solve the problem. So now let me just modify a slight problem over here. Fine. So now I need to find, now the question was something like I need to find the number of arrangements without having no adjacent A's. Now this is the number of arrangements which is going to have adjacent A's. Now without having adjacent A's, how many ways you are going to have? Now you can think about permutation, or you can think about combination, and you can come out with the solution. Just give a thought over here. Fine. So now with this, let us move to the next example or the next concept which the next example do require. Okay, fine. Fine. Now just look at the example what I am putting in front of you. Fine. So now the question reads, or situation is something like a bag contains 7 different denominations that is something, so talking about currency right now, with at least 12 each. That is, I have got 7 different denominations. So let me put it over here. I am going to have denomination D1, it can be 1 rupee coin, and I am going to have denomination 2, the 2 rupee coins, denomination 3, the 5 rupee coins, and so on and so on. I am going to have 7 different types of denominations, and each denomination with at least 12. That is, there are at least 12. It can be more than that, but there are at least 12. Hence, I am going to say this as there are 12 1 rupee coin, there are 12 2 rupee coins, 12 5 rupees, and so on. Each at least is going to be 12, and let me say as greater than or equal to, and so on. Fine. And the next what the question demands is, this is what situation has been given. You have got 7 different denominations with you, and each denomination is at least 12 in number. Fine. The next part of the question, what it reads, in how many ways 12 coins can be selected? I'm talking about selection now. I'm talking about selection. When I'm talking about selection, I'm going to call this as R. As you all already know, R is going to be 12. That is, I know what is R. So now what is N is going to be? Now N is going to, because I don't have any clear picture of how many exact number of coins are there, but I know how many denominations are there. Hence I am going to say this is going to be N. That is, N value is going to be 7 because of 7 different denominations. Hence the value of N is going to be 7. So now I know what is the value of N and R, but now should I use a combination here? Should I use a permutation here? Because this is a denomination. So if I want to pick 12 denominations, and if I want to pick 12 coins, I can pick coin 1 rupee coin first, then 2 rupee coin, then 5 rupee coin, then 10 rupee note, then 50 rupees, then 100 rupees. Irrespective of that, order is irrespective right now, because first I can pick a 2 rupee coin, then I can pick a 1 rupee coin. It is still the same number of coins what I got, and the amount is also same. It never differs now. Picking the 1 rupee coin first or picking 2 rupee coin first, it never matters. Hence the order is not so important right now. Hence I usually think about combination. So now just look here. When I think about combination, I am saying N equals, there are 7 denominations. The first denomination, now when I pick the 1 rupee coin, the first denomination, usually what we were doing, this was out of my selection. Then I had only remaining 6 options. I was picking, because once I pick the 1 rupee coin, I don't have any other way of picking the same coin again. But now if you observe, there are 12 coins. That means I can pick the same coin again and again. I can pick the same denomination again and again. And there is something where I'm thinking about repeating the same thing again and again. I pick the first student as the group 1 member. Again I'm going to pick the same student for the group 2 also. I pick the same student for the group 3 also. Now what exactly I am doing? I am repeating the task with the same object from the given lot. And this is where I think about combination. At the first sight, it has given me a clue that combination should be used. The second important thing is the repetition is required. If there was no repetition, then I cannot solve this problem. Hence for that reason, I've got 2 things to think about here. One is the combination, and the second thing is the repetition. And so now I am talking about combination with repetition. Thinking about combination along with repetition. This is what we are going to talk about. Applying the combination in such scenarios where the repetition is allowed, picking the same object again and again to find the number of ways. That is what we call this as combination with repetition. So now, for that let me put this as C of n comma r, because the first insight, it's a combination. We'll see what the equation ends with, but we are going to have combination. So now if I talk about this combination, now C n comma r, now just look at this. I am going to pick the first denomination. So now how many denominations are available? If it was just combination, then I would have been left out with 6 more denominations. But the repetition is allowed, and the value of n will never get reduced, because there are still more options for me. Hence, if it was combination, I pick one object, I remain with n minus 1. I pick two objects, I remain with n minus 2. But right now that's not the case. Hence n will be constant. But what exactly happening? I was supposed to pick 12 coins. When I pick one coin from the denomination 1, I need to pick how many more coins? R minus 1. Hence R will be keep on reducing. N will stay constant, R will be keep on reducing. Hence how many options you have got? That is n denominations, and the number of object what you want to select after the one selection. That is where I am going to call this as n, and I am going to write this as n plus r minus 1. So instead of just n, now I need to write this as n plus r minus 1, because after picking the first coin, still I am going to have n denomination, which is constant right now for me, but the number of selection has been reduced by 1 after one coin selection. Hence we are going to start the factorial from n plus r minus 1. This is what one change you need to make when you're going to think about combination with repetition. And how many objects you need to select? That is going to be r. Just keep it as r. So now for the same, instead of having C n comma r, I am going to have C of n plus r minus 1 comma r. Hence, so now in place of n, I am going to have n plus r minus 1 factorial divided by n minus r factorial. In place of n, I need to have n plus r minus 1. Now what happens if I am going to have n plus r minus 1? So let me just show it over here. So in place of n, I am using n plus r minus 1 and minus r. So plus r minus r gets cancelled. I remain with n minus 1 factorial. Hence I am going to have this as n minus 1 factorial. Now what about r? So the value of r is same it as. I am going to have this as r factorial. Fine. So this is how exactly you are going to think whenever you are going to think about the combination. When you are going to think about the combination. Fine. Combination along with repetition. That is what. So now this is combination with repetition. I know what is the form. I know what is n. I know what is r. So now just substitute. Use that equation where so C of value of n is 7. So 7 plus the value of r is 12. So 12 minus 1 comma, I am going to have r value is going to be 12. This is equivalent to, so let me write it down here. So 7 plus 12 minus 1 is, so 7 plus 12 is 19, 19 minus 1 is 18, and so we are going to have C of 18 comma 12, C of 18 comma 12, so which is going to be equivalent to, I am going to have, so n plus r minus 1 factorial, now it is 18 factorial divided by n minus 1 factorial is 11 factorial. So n, what's the value of n? N is going to be 5, and this should be 4 factorial multiplied with 12 factorial. Fine. So this is exactly how I am going to use the equations with the appropriate. Okay, fine. So this is how we are going to solve this particular problem. Now we'll just see one more example. One more example how exactly we are going to solve this particular combination with repetition. Fine. Now just take this example. In this example, now what exactly I want to do here is I'm going to have number of non-negative integer. Hence, using this non-negative integer, I need to find a solution, the number of solution which involves only non-negative integers for the given equation. So now, in this case, the number of integers what I am going to choose. So now, this can be any integer, any non-negative integers. Hence, I don't know how many integers are available. And even for this, I don't know exactly how many are available. Similarly for all the 5, but I know there's going to be 5 integers to be having in the equation. Hence, the value of n is going to be 5. So this sum is going to make up. So when I'm going to pick from this lot the 5 integers, this will sum up to me 8. So 8 is going to become my value of r. Hence, r is going to be 8. So now I know what is the value of n, I know what is the value of r, hence selecting x1 first or having x2 first, so x2 plus x1, so order doesn't matter to me for now. Hence we need to talk about combination. Along with that, so x1 can have any number of, I can pick the integer 10, again the same 10 can be picked over here, hence the repetition is also available now. Hence we are going to again think about combination with the repetition. I know what is the value of n and I know what is the value of r. So substitute to this equation, and whatever the value I am going to get in this, that is going to be the number of integer solutions what my problem is going to have the solution. So this is how I am going to think about the combination with the repetition. So now this is the first way or the first case where exactly I am going to think about combination. So whenever I am going to have a scenario. So now you have got 3 types of scenarios what you can put into. A scenario where arrangement is required, think about permutation. A scenario where the order is not so essential, think about combination. And when the order is not essential, but you can select the same object again and again, think about combination with repetition. So now with this, I am just going to give one more instance where exactly the combination can be used. Fine, just look at this. Fine, now just look at this. The next way of how exactly we are going to use the combination is, so the combination we can say it's the basic property whenever you want to find the coefficient of a binomial theorem or multinomial theorem. The combination becomes a basic property, remember, whenever I want to find the coefficient of a given multinomial or binomial theorem. So now, these are the few of the examples where I have written the binomial theorems. When I say binomial, the 2 variables are involved, x plus y and so on, and this is the expansion of x plus y, x plus y whole square, x plus y cube, whole cube, this is expansion. Similarly, I am going to a multinomial. So where the multinomial is, I am going to have 3 variables here or more than 2 variables, what we call this as multinomial. Hence, I am going to have a plus b plus c whole square, and this is the given expansion. So now whenever I want to find the coefficient, that is, now the coefficient of xy is 2, the coefficient of x to the power of 4y is 5, and this is what I need to find. So now if I am going to give you an binomial equation and I am going to ask you to find the coefficient, fine. So what exactly you will do? You will just go through this, and you are going to see that how exactly you are going to expand. After expansion, you will find for the factor, and for that factor whatever the coefficient is going to, you are going to note it down. So this is how you need to do. For example, I am going to give a binomial equation where I am going to have 2x minus 3y to the power of 12. I need to find the coefficient of, x to the power of 9, y to the power of cube. I need to find this coefficient. Now how do you do this? You need to expand this first and later on search for this particular factor, and this particular coefficient will be a solution. So this becomes an hard task to do, which is time consuming as well as something somewhere it can go wrong. For that reason we are going to have an equation to help you out. Fine. Now whenever you want to find the coefficient of any given such scenarios, you can make use of, if it is a binomial equation, something like this, you can think about this binomial equation, binomial form to find the coefficient. If it is a multinomial, you can think about this form. I written two forms here. This is the form for binomial and this is the form for multinomial. Even this also can be used for binomial, which you can verify it later. But right now, just to put in general case, this is the form for binomial and this is the form for multinomial. Fine. So now we'll just see exactly how we are going to find something. When I say x to the power of 9, 5 to the power of 3, something like I have given x to the power of 4y in the expansion of x plus y over the power of 5. What is the coefficient? This was the question. Similarly, I am going to put it over here. So I am just going to help you out to see how exactly this should be solved, and I am going to tell you what is the coefficient of this given using binomial. Fine. So now in this given problem, I am going to have x plus yn. X plus yn is going to be 2x minus 3y. I am going to have 2x minus 3y whole to the power of 12. Hence the value of n is going to be 12. The value of x is replaced with 2x and y is replaced with minus 3y. So this is equivalent to summation of r equals 0 to n is going to be 12, hence replace this with 12, and whatever the symbol I have used here, this is something equivalent to combination. This is NCR or C of NR, which I can also write like this. Right? This is equivalent to NCR or C of NR. Hence I am going to have the value of n is going to be 12, the value of r is going to be still unknown, hence I am just going to write as r, and in the place of x I am going to have 2x to the power of r multiplied with, in place of y I am going to have minus 3y to the power of n is going to be 12, so 12 minus r. So this is what I have replaced n with 12 and replace x with 2x and y with minus 3y for the given form. This is what I am going to end with. So now just to go forward, so let me simplify this as r equals 0 and this is 12. I am going to have 12 r and I am going to have this as 2 to the power of r. I am going to separate this x multiplied with minus 3 to the power of 12 minus r multiplied with x to the power of r into y to the power of 12 minus r. Fine. I have just separated this. Now just look at these factors now. I am going to have x into y, so which I can relate with the given component, that is x. As I am going to have now x to the power of 9, y to the power of 3. So this is the factor of coefficient which I need to find. Now this is entire thing is going to be my coefficient and this is going to be the factor. Now the given factor is x to the power of 9, y to the power of 3, which is equivalent to x to the power of r and y to the power of 12 minus r. So now I can now easily write x to the power of 9 is equivalent to x to the power of r. So directly I can say r equals 9. Hence I know what is r now. Or else I can relate y powers, that is, so 3 equals 12 minus r. I am going to have 3 equals 12 minus r, and you can simplify this and you can check it out. R will again stand at 9, hence r is going to be 9. You can use any way. I can use the power of x to find r, I can use the power of y to find r. Any one way you can use. So now I know what is the value of r. When I know what is the value of r, I need not start r from 0, I need not reach 12. I am just going to substitute this as c. So c of 12 comma 9 multiplied with 2 to the power of 9 multiplied with minus 3 to the power of 12 minus 9, which is going to give me 3. It is going to give me 3. So solve this. So you know what is the combination formula. Apply the combination formula here and simplify this. You are going to get what the solution is going to be. So this is how we are going to solve to find the coefficient of any given factor for any given expansion if it is going to be binomial. Fine. So now similarly let us just look one more example and see how exactly we can make use of the multinomial equation. So this is the given multinomial equation which I need to expand later on, and I need to find what is the coefficient of this given factor. Now how do I do this? So now if it's a multinomial, just use the multinomial form, and you know what is the value of n. I just need the value of n for this, hence I know what is the value of n. N is going to be 7, and what is n1? n1 is going to be whatever the factor of x is going to be, factor of n2 and the factor of n3 for z. Hence I am going to have n1 equals going to be 2 and n2 is going to be 2 and n3 is going to be 3. I know what are the three factors, and so now I am just going to substitute to this equation. This is equivalent to 7 factorial divided by, because this is something like we are going to have combination again, n factorial divided by n1 factorial into n2 factorial, so on. Hence I am going to have 7 factorial divided by 2 factorial multiplied with 2 factorial multiplied with 3 factorial. Fine. So now this should be multiplied with what is x1 now? x1 is the first component, that is going to be 3x. I am going to have 3x and x1 is 3x and n1 is 2, hence is going to be 2 now. Again multiply this with minus 2y, which is x2 to the power of n2, which is 2. Multiply this with minus 4z to the power of n3, which is 3. I am going to have this as an equation. Fine. So now just to simplify this, I am going to have 7 factorial divided by 2 factorial into 2 factorial into 3 factorial. So take all the coefficients at one end and the factors at other end. Multiplied with 3. So this was supposed to be whole square, and so 3 square multiplied with minus 2 whole square multiplied with minus 4 whole cube, and the remaining part as the factor is going to be x square into y square into z cube. That is what? X square, so y square and the z cube. Now this is going to be the factor, and if I am going to simplify or calculate this, this is going to be my coefficient and this is going to be my solution. So this is how we are going to think about the multinomial and how exactly I am going to bring in the concept of combination whenever I want to find the coefficient of a given binomial and multinomial. So this was all about the module 2, where we started with the mathematical induction, then we talked about recursive definition, then we talked about the product rule and the sum rule, through which we derived the permutation, the combination with the repetition, and we ended with making use of combination to find the factors or the coefficient of binomial and multinomial theorem. Fine. So thank you for this session, and please give a try on this following problems and understand more about the complete principle of counting.